Here is our Weston shunt. It is about 11.5 inches this way and about 10.5 inches this way. If you don't count those handles, it's about 6 3/4 inches. This giant piece of copper is 1 7/8 by just shy of a 1/2 inch this way. It's heavy for its size for sure, but you can pick it up. It might be a little hard to pick it up with one hand, but I can do it all right. Campbell soup can for scale. Campbell soup cans are a little small actually, so here's a regular can of beans for you. The binding posts are enormous. And these are fine threads, so it takes forever to screw this back in. This is a solid piece. There we go. That is 1 3/4 by looks like 3/8, and it sits about 1 1/8 off of our copper bar. The height is about 4.5 inches. The underside of this is also kind of cool looking, if you ask me. You should be aware that it has feet, right? So these feet let it stand off of whatever it's sitting on so that you can get some airflow. Because the idea is if you're dumping a lot of current through this thing, it's gonna get hot, right? So these feet are intact on this side and this side, but this one has a bit missing, and you can see this one is missing a lot of it. If that really bothers you, I can look around and see if I have some rubber feet to replace it with. But I decided to leave it as is. It's kind of interesting on the inside of this thing too. So let me unscrew this and show you what it looks like. This is what it looks like on the inside. I can tell you from experience that taking one of these off is a bad idea, because then you have to index every single one of these little pieces of metal into one of the slots. Under normal operation, of course, that would stay on. These are another set of binding posts. So this is so that you can put a meter on and measure what's going on at either one of these, through these terminals. I Again, under normal circumstances, you would leave this on. It may have never actually come off of this device in its lifetime. Here we go. There's the Weston Shunt.